Hello and welcome to this part 8 of AWS Certified Solution Architect full crash course. Let's dive into security. Welcome to this overview of identity and access management services. Let's dive into what IAM actually means and how it works. IAM involves two key components, identity management and access management. Identity management is about defining who you are and verifying your identity. For example, your AWS username serves as your unique identity within IAM. Access management, on the other hand, focuses on authorization and access control. It determines what resources an identity can access within your AWS account. These include permissions for specific AWS resources such as EC2 or RDS. Access control is achieved through various authentication methods, including username and password, multi-factor authentication, and federated access. These mechanisms ensure secure access to AWS resources without compromising user credentials. In essence, IAM enables the management, control, and governance of authentication, authorization, and access control mechanisms within your AWS account. Understanding these security controls is crucial for designing the right level of security for your infrastructure. If you're looking to enhance the security of your AWS account, understanding AWS IAM for secure cloud management is essential. IAM, or identity and access management, is crucial for maintaining security and control over who or what can access your resources. It provides the components to manage access, but it's up to you to configure it securely. You must define access control procedures, restrict user access, set password policies, and consider multi-factor authentication based on your security standards and policies. IAM consists of various components like users, user groups, roles, and policies. Users represent identities, while user groups authorize access to resources. Roles allow temporary permissions, and policies define access. Managed and inline policies offer different ways to manage access, and federated access allows external credentials for authentication. Access Analyzer helps identify external access to your resources, while the credential report provides insights into user credentials and activity. AWS organizations and service control policies further enhance security by setting boundaries for permissions. So understanding AWS IAM is essential for maintaining a secure cloud environment. So take advantage of these features to strengthen your AWS account security. You probably heard about the AWS account root user. Let's dive into what it is and why it's so important. When you first create an AWS account, it generates the AWS account root user. This user has full access to all resources and features in your AWS account, making it an ultimate administrator. The root user has a huge amount of responsibility and should be used with extreme caution. Specific measures and security restrictions should be linked to the root user to restrict its use and accessibility. There are specific tasks that only the AWS account root user can carry out, such as altering account settings, enabling IAM Identity Center, registering as a seller, activating IAM access for billing and cost management, closing the AWS account, and more. It's essential to understand how to protect the root user. It's recommended to use the root user only for specific tasks and to use an IAM user with administrative privileges for any other administrative action. The root account is powerful and important, so it's crucial to adopt security hardening operations to protect it. Remember, when you're signing in using the AWS management console with the root user, you will need to use an email address different from your IAM user accounts. And welcome to this short course on securing your AWS root user account. Let's dive into some best practices to enhance the security of your AWS root user account. To start, implementing multi-factor authentication for the root user is crucial. MFA adds an extra layer of security, requiring a second step of authentication after entering the password. Next, consider deleting the access keys for the root account. These keys, if compromised, can make your entire account vulnerable. Regularly changing the password for the root account is another essential practice. Ensure the password is strong and unique, using a mix of symbols, numbers, upper and lowercase letters. Lastly, setting up security challenge questions on your account can further improve your AWS account security posture. By implementing these best practices, you can significantly enhance the security of the most important user within your AWS account, the root user. Welcome to a comprehensive review of AWS IAM User Control Dashboard. Let's dive into the key features and functionalities of these essential tools. When you access the IAM dashboard and select users, you will find a summary screen that provides crucial insights into your IAM users. It helps you identify potential security risks, such as inactive accounts with color-coded warnings. The dashboard displays a range of user details, including username, path, groups, last activity, MFA status, password age, console sign-in, access key details, and more. Each of these details offers valuable information for managing user access and security. By leveraging the IAM User Console dashboard, you can efficiently manage your access, identify security risks, and ensure compliance with best practices. It's a powerful tool for maintaining a secure and well-organized AWS environment. So stay tuned for more insights on optimizing your AWS experience. And thank you for watching. Welcome to creating a new user in AWS Management Console. Creating a new user in the AWS Management Console is a simple process. First, set the user details by creating a username, then select the AWS access type, either AWS Management Console access or programmatic access. You can attach permission policies to the user, assign permissions boundaries, and add tags to the users as you would with any other AWS resources. Review and confirm the information submitted before creating the user. Once the user is created, you can download the security credentials via a CSV file containing the username, access keys, and the console login link. And that's it. Creating a new user in the AWS console is quick and easy. Now let's dive into the additional features and security options available for IAM users. First, let's talk about the user details and permissions. We can view the user's permissions, set permission boundaries, and generate policies based on CloudTrail events. Moving on to security credentials, we can manage the user's password, set up multi-factor authentication, and manage access keys. Lastly, the Access Advisor allows us to review the services that users can access and the associated permissions, helping us ensure users have appropriate access. That's a quick overview of the key points for configuring IAM user properties. Stay tuned for more insights on user management and security options. If you're struggling to manage permissions for multiple users in your AWS account, let me introduce you to IAM user groups, a powerful feature that simplifies access management at scale. IAM user groups are subjects that contain IAM users and have IAM policies associated with them. These policies can be AWS managed, customer managed, or inline policies, allowing or denying access to AWS resources. By applying permissions to a group instead of individual users, it becomes easy to modify permissions for multiple users at once, simplifying access management at scale. It's a security best practice to apply permissions to user groups and then associated users to that group, then to associate policies to individual users. Creating a group is a simple three-step process. Give the group a meaningful name, add users to the group, and attach permissions via policies. Once created, you can easily review its configurations, edit permissions, and see other details. IAM user groups are a game changer for managing multiple users in your AWS account, simplifying your access management and enhance security by leveraging these powerful features. Have you ever wondered how IAM roles works in AWS? Let's dive in and find out. IAM roles are identified with assigned permissions, just like users, but they are designed to be assumed by multiple different entities as and when required. When a role is assumed by a user, an AWS service, or an application, a new set of credentials is dynamically created for the duration of that session, without any long-term credentials associated. IAM roles are used for granting temporary access to AWS resources, allowing IAM users in one account to access resources in another, enabling AWS services to access resources on your behalf, and providing federated users with access to specific resources. For every role, there are associated policies controlling access, as well as trust relationship that define who or what can assume the role, such as user, an AWS account, or an AWS service. IAM roles are a powerful tool for managing access to AWS resources, providing a secure and flexible way to control permissions. So next time you need to grant temporary access or enable an AWS service to access resources, consider using IAM roles for a secure and efficient solution. Are you curious about AWS service roles and how they can benefit your AWS resources? Let's dive into understanding the power of AWS service roles and how they can simplify your access management. An AWS service role allows an AWS service to assume a role to access other AWS resources within your own account on your behalf. This is commonly used for EC2 instances, whereby you could create a role for an EC2 instance to assume to gain access to AWS resources on your behalf. By assigning an IAM role to an EC2 instance, you can easily manage permissions and make changes across multiple instances simultaneously. This eliminates the need to manually manage credentials and ensures a more secure and efficient access management process. In addition to AWS service roles, there are also service linked roles, which come pre-configured with specific read-only AWS managed policies. These roles are designed for specific AWS services and provide a secure and controlled way for those services to interact with other AWS resources. Understanding AWS service roles is essential for optimizing access management within your AWS environment. By leveraging these roles, you can streamline access, enhance security, and simplify permissions management across your AWS resources. If you're looking to grant temporary access to AWS resources for a specific user, you need to understand and explore the best approach to these common challenge. When it comes to granting temporary access to AWS resources, the best practice is to allow the user to assume a role with the necessary permissions. This approach replaces all other permissions the user has, ensuring a secure and controlled access. To create a new role with relevant permissions, you will need to define the trusted entity and set up an access policy. This ensures that only specific users can assume the role, preventing unauthorized access. In the AWS Management Console, navigate to the IAM dashboard and follow the steps to create the role with the required permissions. Then add an inline policy to the user to enable them to assume the role. IAM user roles provide a secure way to grant temporary access to AWS resources, ensuring controlled and monitored permissions. If you're looking to understand how federated users can access your AWS resources using roles, let's dive into two options available: Web Identity and SAML 2.0 Federation. When creating a new mobile application that requires access to Amazon S3, embedding long-term credentials into your application code goes against security best practices. Instead, design your application to request temporary credentials from authenticated users through Web Identity Federation. Identity Federation is a method of authentication where two different providers establish a level of trust, allowing users to authenticate from one, which authorizes them to access resources in the other. In the case of your application on AWS, the web identity provider could be Google or Facebook. For example, SAML 2.0 is generally used to authenticate your employees using existing directory services. It's a standard used to exchange authentication and authorization identifiers between different security domains, which uses security tokens containing assertions to pass information about a user between a SAML identity provider and a SAML consumer. Understanding these two methods of federation access using roles in AWS is crucial for managing access to your resources. Whether it's for a large-scale access from unknown user or authenticating your employees using existing directory services, AWS provides the necessary tools for secure and efficient access management. AWS IAM policy types. Let's explore the four main policy types within AWS IAM and how they function. Let's start with the identity-based policies. These policies are attached to users, user groups, or roles, controlling their permissions. They can be either managed or inline policies, offering flexibility in managing access. Moving on to resource-based policies, unlike identity-based policies, these are associated with resources such as S3 buckets or IAM roles. They define which principals can access the resource based on different actions. Next, we have permissions boundaries. These policies set the maximum level of permissions that can be granted to a user or role, acting as guide rails to limit access. Lastly, we will discuss service control policies. These are used at the AWS account level to define the maximum permissions allowed for members, adding an additional layer of security. So understanding these policy types is crucial for effective IAM management. If you're delivering web content through CloudFront distributions, Amazon API Gateway REST APIs, or application load balancers, then you need to hear about the AWS WAF service. The AWS Web Application Firewall service is a crucial layer of security to protect your web applications from harmful and malicious traffic. It helps prevent attacks like SQL injection and cross-site scripting outlined in the OWASP top 10 list. Implementing AWS WAF is a huge asset to your web application architecture, providing relief to security officers within your organization. It's quicker to deploy and simpler to manage compared to standard WAF solutions. The service is composed of web ACLs, rules, and rule groups, which work together to filter both HTTP and HTTPS requests, allowing only legitimate traffic to be processed. Imagine AWS WAF associated with a CloudFront distribution. The incoming web traffic is filtered using rules or rule groups before it even reaches your CloudFront environment. So by implementing AWS WAF, you can mitigate vulnerability risk and protect your web application from potential security breaches. Let's dive into the world of AWS WAF rules and rule groups. These are crucial for defining inspection criteria to secure your web ACLs effectively. Let's start with managed rule groups. These are predefined rules created by AWS and other sellers designed to protect against specific vulnerabilities. They save time and effort, and each group has a capacity rating, which is important to consider when applying them. Now let's talk about creating your own rules. You can choose from IP set, rule builder, or rule group. For example, with IP sets, you can configure rule criteria based on source IP addresses or IP addresses in headers. The rule builder option allows you to create rules using a visual editor or a JSON builder. Regular and rate-based rules are available, each with specific actions and logic options. Lastly, rule group need to be built outside of your web ACL creation. You can create and add rules and specify the maximum capacity WCUs for future planning. Welcome to this overview of AWS Firewall Manager. Let's dive into what these powerful service is all about. AWS Firewall Manager specifies security management across multiple AWS accounts, providing protection for a range of resources. Its ability to work across multiple account infrastructures gives it significant security power. Once security policies are configured, AWS Firewall Manager automatically applies and manages the protection for existing and new resources across all designated accounts, streamlining security efforts across your entire organization. Firewall Manager provides protection for various AWS resources and services and resources, including AWS WAF, AWS Shield Advanced, AWS Network Firewall, VPC security groups, and Amazon Route 53 Resolver DNS Firewall, all closely integrated with AWS organizations. To begin using Firewall Manager, you will need to designate an AWS account as the Firewall Manager Administrator account. Ensure it's part of an AWS organization and configure AWS config for the account and regions where resources reside. With these initial steps completed, you're ready to start configuring AWS Firewall Manager and its policies. Let's deep dive into configuring AWS Firewall Manager policies. Let's explore the different types of policies and their configurations. AWS Firewall Manager allows you to create policies protecting AWS WAF, Shield Advanced, Network Firewall, Amazon VPC, Security Group, and Amazon Route 53 Resolver DNS Firewall. To configure an AWS WAF policy, you will go through a 5-step process. These include choosing the policy and region, describing the policy, defining the policy scope, configuring policy tags, and reviewing and creating the policy. For the AWS Shield Advanced policy, the configuration process is simpler, with steps for describing the policy and defining the policy scope. When configuring the security group policy, you will also select the security group policy type, such as common security groups, auditing and enforcement of security group rules, or auditing and clean up unused and redundant security groups. Understanding the configuration process for each policy type is crucial for effectively managing and securing your resources across multiple accounts. Welcome to a crash course on DOS and DDoS attacks. Let's dive into and understand what these attacks are and how they work. A denial of service attack aims to deny users access to a computer system or application by overwhelming it with bogus requests. On the other hand, a distributed denial of service attack involves multiple sources of bogus requests, making the volume of attacks massive and challenging to mitigate. DDoS attacks require a network of compromised computers known as botnets, controlled by botmasters through command and control servers. These servers are used to remotely send commands to the botnet, initiating a coordinated attack. There are various types of DDoS attacks, such as the ping flood and SYN flood. Ping flood overwhelms a victim computer with pings, consuming sufficient bandwidth, while SYN flood attacks to make a system unresponsive to legitimate traffic by consuming server resources. Mitigating these attacks involves careful network design, configuring of protection devices, and having an effective business continuity plan in place. Understanding these attacks is crucial for safeguarding against them. Now, welcome to a quick guide on understanding AWS Shield and its protection levels. AWS Shield is a managed service designed to protect your AWS applications and resources from distributed denial of service attacks by automatically detecting threats that may impact your environment. There are 2 protection levels offered by AWS Shield. AWS Shield Standard, free and offers protection against common layer 3 and layer 4 DDoS attacks. AWS Shield Advanced provides enhanced protection against a wider scope of AWS services, including layer 7 application attacks, but comes at an additional cost. Enhanced DDoS protection, 24/7 specialized shield response team, layer 7 protection and integration with AWS WAF, enhanced monitoring and Route 53 health checks, cost protection and integration with AWS Firewall Manager. These are the key features of AWS Shield Advanced. So both versions provide insights into DDoS events, but AWS Shield Advanced offers additional monitoring features and CloudWatch metrics. So before subscribing to AWS Shield Advanced, consider the additional cost and features. Let's discover the power of AWS Security Hub, a tool that consolidates security findings and alerts across accounts and provide products displaying results in a single dashboard. With AWS Security Hub, you can centrally view and manage security alerts, automate security checks, and seamlessly integrate with multiple AWS services like Amazon guardduty, Amazon Inspector, and Amazon macie. It also integrates with third-party products and services, offering over 60 integrations from vendors like Symantec, Splunk, and Palo Alto Networks. Security Hub runs continuous account level configuration and security checks based on AWS best practices and industry standards, providing readiness scores and identifying specific accounts and resources that require attention. So experience the ease of collecting, prioritizing, and remediating security findings with AWS Security Hub, your all-in-one security management solution. Let's discover how AWS Security Hub automatically implements these three fundamental standards as designed by the Center for Internet Security, or CIS, to safeguard your AWS infrastructure against cyber threats. AWS Security Hub supports these standards, which includes enabling multi-factor authentication for all accounts users, defining a robust password policy, and ensuring no publicly accessible Amazon S3 buckets. These actions are crucial for securing your AWS account. These benchmark focuses on AWS configuration best practices for security, including monitoring and logging. Once enabled, AWS Security Hub automatically checks for your compliance with these benchmarks. The PCI DSS standard applies to the storing and processing of credit card information in your AWS implementation. AWS Security Hub serves as your central point of access to verify AWS security and take appropriate action when needed. Take AWS security seriously and ensure that best practices are defined, implemented, and regularly reviewed. AWS Security Hub simplifies the process of collecting and remediating security issues in your AWS infrastructure, helping you protect your business from potential losses. If you're struggling to manage the insignificant volume and categories of security information generated by your services, let's explore how AWS Security Hub can simplify these processes and ensure a secure and compliant environment. The information generated by security services can be overwhelming, making it challenging to maintain a secure and compliant environment. AWS Security Hub provides a centralized platform to access and automatically verify the application of best security practices as defined by AWS experts. Foundational best practices for AWS accounts. When setting up new AWS accounts, it's crucial to adhere to fundamental best practices. These include securing the root user with multi-factor authentication, creating groups with administrator permissions, and provisioning users with access keys and roles. Utilizing groups for permissions and provisioning keys and roles to users is an efficient mechanism for your provisioning. It's essential to avoid storing access keys in code and EC2 instances or Amazon S3 buckets for maximum security. AWS offers a range of tools, including machine learning based solutions to automate provisioning, monitoring, and auditing for cloud security compliance with best practices. So by implementing these fundamental security best practices and leveraging AWS Security Hub, you can ensure a secure and compliant environment while simplifying the management of security information. Exciting news for AWS users. Let's dive into the integration and benefits of AWS Security Hub. AWS Security Hub seamlessly integrates with Amazon guardduty, Amazon Inspector, Amazon macie, and more, serving as a centralized platform for security findings. These means that findings from these services are automatically sent to Security Hub, streamlining security management. Security Hub utilizes AWS config rules for security checks and supports integration with Amazon EventBridge for automated notifications and remediation details. These ensures continuous account-level security checks based on best practices and industry standards. The platform displays results from over a dozen AWS services, including AWS Firewall, Systems Manager, Patch Manager, and Identity and Access Management Access Analyzer. This comprehensive integration provides a holistic view of security findings. Let's explore the benefits of the integrated services such as Amazon Inspector, Amazon guardduty, and Amazon macie to understand the value they bring to AWS Security Hub. So stay tuned as we will delve deeper into the benefits and sample findings from these integrated services, highlighting the power of AWS Security Hub. Are you responsible for the security of applications, process, and tools running on EC2 instances? Amazon Inspector is here to help. Amazon Inspector offers a knowledge base with hundreds of rules mapped to common security compliance standards and vulnerability definitions. These rules are regularly updated by AWS security experts. You can also install an agent in the operating system of an Amazon EC2 instance to monitor behavior like network, file system, and process activity. With Amazon Inspector, you can automate vulnerability assessments to make security testing of EC2 instances a regular part of your cloud operations. As a result, you will receive a prioritized list of findings ensuring the security of your EC2 instances. Amazon Inspector, your solution for securing EC2 instances. Protect your AWS accounts. Looking for a reliable way to monitor and protect your AWS accounts and workloads? Amazon guardduty is a solution. It uses machine learning models to identify suspicious behaviors and eliminates false positives by learning from your environment. Guardduty analyzes CloudTrail logs, VPC flow logs, and DNS query logs to provide accurate findings. Sample findings help you understand the results it delivers, and it seamlessly integrates with AWS Security Hub. Results are classified under low, medium, and high severity, with each category marked by a distinct color and symbol. The findings summary gives you a quick overview of the severity categories. Discover and analyze sensitive data stored in Amazon S3 buckets with Amazon macie, using machine learning to identify personal identifiable information like names, address, credit card numbers, API keys, and access credentials. macie scans S3 buckets, recognizing critical private information and automatically tracking changes to evaluate new or modified objects in future scans. This approach significantly enhances efficiency and scalability by avoiding the review of unchanged objects. Amazon macie provides a list of findings displaying severity, finding type, affected resources, and the last scan date. For example, it identifies objects with medium or high severity, categorizing them as personal, financial, or credential related, and indicates when the object was last scanned. Are you tired of hustle of setting up user authentication for your applications? So you're not alone. Dealing with user authentication can be tedious and time consuming, especially when determining who is allowed to access specific resources. In the past, user information was stored in traditional databases, requiring significant effort to set up and maintain. But there's a better way. Amazon Cognito, a powerful yet compact service, can streamline the entire process from managing user data to integrate with existing corporate directory services. Say goodbye to the headaches of user authentication and hello to a more efficient application development experience. Welcome to a quick guide on Amazon Cognito, user pools and identity pools. Amazon Cognito user pools are user directories that provide sign in and sign up options for your app users. They also support user profiles, including a customizable user directory that scales to hundreds of millions of users. Now let's dive into Amazon Cognito identity pools. These pools enable you to create unique identities for your users and authenticate them with identity providers. These allow you to obtain temporary AWS credentials to access other AWS services. Understanding the difference between Amazon Cognito user pools and identity pools is crucial for leveraging the full potential of Amazon Cognito. So stay tuned for more insights on cloud services. Introducing Cognito user pools. When signing up new users, Cognito lets you customize what is important for you and your application. You can have your new users submit their emails, addresses, pictures, and more. You can create custom attributes and specify how stringent you want to be with your user passwords. Cognito provides multi-factor authentication and account recovery features, making it ideal for financial services or applications with high value information. Users can sign in using third-party ID providers, and you can also sign in with any SAML identity provider. You can create your own customizable web UI and integrate with AWS Lambda to trigger functions based on user flows. Cognito user pools simplifies the process of user management, authentication, and sign-in, allowing you to focus on developing your application. In the authentication flow, the user submits their credentials, initiating the process. The application then calls the initial authorization operation, signaling to Amazon Cognito the intent to authenticate. If successful, Cognito responds with a token or a challenge, which may include captchas or custom challenges. The client then responds to the challenging using respond to auth challenge. If the user fails the challenge, Cognito can resend a new one. Upon successful authentication, Cognito provides token for the clients to use. Learn about Amazon Cognito identity pools. Amazon Cognito identity pools, also known as federated identities, provide temporary access AWS credentials for users or guests needing access to AWS services. There are two types of identities within the identity pool: authentication identities and unauthenticated identities. Each type of identity has a role with policies attached to set permissions for accessing AWS resources. Differentiate between identity pools and user pools. Identity pools are for authentication and access control for AWS services, while user pools are for sign up and sign in operations. All right, let's dive into how authentication works with identity pools. Your application can have the user sign in with Cognito user pools using the user pool itself. Social sign-in, SAML-backed authentication service are similar methods. Once the user sign in, an identity token is sent by the IDP back to the Cognito user pool. This token is then normalized into a Cognito user pool token and stored by Cognito, allowing standardized access to your app regardless of the authentication method. For accessing backend services or APIs, Cognito uses the cup token to authenticate an authorized usage of services like API, Gateway, or Lambda. If your app needs access to services like S3 or DynamoDB, the identity pool is used for authentication, creating an STS token based on the CUP token, allowing access to these services. These AWS credentials are linked to an AWS role associated with your user within the identity pool, enabling access to other AWS services. Now let's understand what AWS Identity Federation, what it is and how it works. Identity Federation is a method where two different providers establish trust, allowing users to authenticate from one, which authorizes them to access resources in the other. One party acts as an identity provider and the other as service provider. Think of websites where you can log in using existing credentials or authenticate using credentials from a third-party provider like Google or Facebook. This is similar to how Identity Federation works. AWS offers various services and methods that allow you to access your AWS services via federated access, including Auth 2.0, OpenID Connect, and SAML 2.0. In summary, AWS Identity Federation provides a flexible and scalable way to manage access control systems. Services like AWS Single Sign-On, AWS IAM, and Amazon Cognito play a crucial role in implementing federated access. Thanks for joining me. I hope you now have a better understanding of AWS Identity Federation and services involved. Now let's explore the AWS IAM Identity Center and its core features. IAM Identity Center is a centralized hub for managing user authentication and access to AWS accounts and applications. It simplifies access control for workforce identities across multiple accounts, streamlining security management. One of the key features is the ability to create workforce identities within the center or synchronize them from an existing identity source like Microsoft Active Directory or Okta. It also enables single sign-on access to cloud-based applications, including SAML 2.0 enabled applications. To use IAM Identity Center, you need to be using AWS organizations and tie it to your management account. This allows for a multi-account access strategy and centralized management of AWS accounts. In summary, IAM Identity Center provides a seamless single sign-on approach for workforce identities to access multiple AWS accounts and cloud-based applications, making access management more efficient. Let's dive into the high-level steps you need to take to get started with IAM Identity Center in your AWS infrastructure. Before configuring IAM Identity Center, it's crucial to review your current identity sources, such as Active Directory or external identity providers. These will save you time and effort by syncing data from your existing source. Once you have taken care of the considerations, you can enable IAM Identity Center within your management account. Define your identity store, configure permissions for your multi-account architecture, and create administrative level permission sets. Associate these permissions with a group or user within your AWS accounts. If you are using the default identity store, create new users easily within the IAM Identity Center. Finally, use the AWS Access portal to sign in and connect to a wide range of AWS accounts and applications, all without creating IAM users accounts in each AWS account. By implementing IAM Identity Center, you will have a robust authentication system in place, ensuring secure access to your AWS infrastructure. Welcome to our discussions on controlling access with AWS permission sets and groups. So when creating permission sets from within IAM Identity Center, you have two methods to choose from. You can use predefined permission sets, such as database administrators, network administrators, data scientists, administrator access, read-only access, and more. Or you could create a custom permission set, offering greater flexibility in granting permissions for users or groups. Regardless of the method you choose, there are some configuration elements that apply to both. You need to supply a name for the permission set, specify the session duration, and an operational relay state. You can also add an optional tag for management purpose. For custom permission sets, you have the flexibility to add a combination of AWS managed policies, customer managed policies, inline policies, and permission boundaries. You can view the name, description, ARN, and provisioned status of the permission sets in the console. Provision means the permission set is in use, while not permissioned means it hasn't been associated with a group or user. It's a good practice to assign permission sets to groups instead of individual users, allowing you to control access for more users at a time. So welcome to a quick guide on application assignments and IAM Identity Center. Let's dive in. To begin, you will need to add your cloud applications to AWS IAM Identity Center. This involves establishing a trust between the application and your IAM Identity Center. You can choose from a library of pre-integrated cloud applications or opt to add a custom SAML 2.0 application. Once you have selected an application such as Slack, you will be guided through the configuration process. This includes providing a name and description of your application, as well as supplying IAM Identity Center metadata details to your cloud application. You will also have the opportunity to adjust optional application properties such as the application start URL, relay state, and session duration. These are optional and can be left blank based on your specific use case. Finally, to assign permissions to your applications for your workforce users, simply select the application from application assignments, choose the required groups or permissions, and assign users. It's simple as that. With these steps, you can seamlessly integrate your cloud applications with IAM Identity Center, providing a single sign-on approach for your workforce users. Let's dive into the service-specific settings of IAM Identity Center. Let's explore the key configuration and options available to you. When you access the settings page from the dashboard, you will find essential details such as ARN of your IAM Identity Center, the region it resides in, an option to set a delegated administrative account and enable Identity Center applications in member accounts. The delegated administrator account allows you to manage your IAM Identity Center from outside of your management account, reducing the number of users needing access to the management account and minimizing security risks. You can define whether to share identity information with multiple accounts within your AWS organization and configure the Identity Center enabled applications based on your preferences. The settings page also provides information on identity source, authentication, and management, including options for identity source selection, authentication configuration, and management controls. Understanding these service-specific settings is crucial for effectively managing your IAM Identity Center. So stay tuned for more insights on optimizing your AWS services.